Hi, 6th grade. Today we will be discussing more about mean absolute deviation. As we discussed yesterday, absolute deviation is the distance between each data value and the mean. You can find the absolute deviation from the mean by computing the absolute value of the difference between these numbers. The mean absolute deviation, or MAD as you'll see it called, tells how far a typical data value is from the mean. We can find the MAD by adding up all the absolute deviations and then dividing by the number of values. Let's revisit this problem from yesterday. Joey raises rabbits. 6 different litters yielded 5, 10, 8, 12, 1, and 6 rabbits. Yesterday, we found the absolute deviation for each of the 6 litters. Today, let's find the mean absolute deviation. So we already found that the first litter had an absolute deviation of 2, the second had an absolute deviation of 3, the third was 1, and then 5, 6, and the last one had an absolute deviation of 1. If we want to find the mean absolute deviation, it's pretty simple. We're just going to find the mean of all of those numbers I just circled. So 2 plus 3 plus 1 plus 5 plus 6 plus 1. That all adds up to 18. Now, since there were 6 different litters, we can do 18 divided by 6, which is 3. On average, each data value was 3 units away from the mean. Let's look at one more situation. Jamie raises rabbits as well. 6 of her rabbits yield litters of 7, 5, 7, 8, 6, and 9 rabbits. We're going to find the MAD of this data. Did the number of rabbits vary more for Joey or for Jamie? In order to find the mean absolute deviation, I need to find the mean. Let's add up 7 plus 5 plus 7 plus 8 plus 6 plus 9. Altogether, that makes 42. To find the mean, I'm going to divide the total by the number of data values, 6. This means that the mean of Jamie's data is 7. This value should look familiar. That's because this is the same average number of rabbits that were in each of the litters Joey had. Since the means are the same, it's tempting to say that the data sets are too. It's going to be up to the mean absolute deviation to help us compare the variability of each data set. Let's calculate each absolute deviation first. So the first litter yielded 7 rabbits. The absolute value of 7 minus 7 equals the absolute value of 0, or just 0. The absolute value of 7 minus 5 is the same as the absolute value of 2, or 2. Again, we have another 7 minus 7, and the absolute value of 0 is 0. The fourth litter yielded 8 rabbits. 8 minus 7 is 1, and the absolute value of 1 is also 1. Let's do that with the fifth and sixth data value as well. We have another absolute deviation of 1, and now 9 minus 7 is 2, and the absolute value of that is also 2. Now I'm going to add up all these absolute deviations in order to find the mean. 0 plus 2 plus 0 plus 1 plus 1 plus 2 gives us 6. Since there are 6 values, 6 divided by 6 is 1. The mean absolute deviation of Jamie's data is 1. On average, each data value is 1 unit from the mean. If we want to see which group of rabbits varied more in terms of number of baby rabbits per litter, let's look at the mean absolute deviation. A higher value for a measure of variability means more variability. In other words, Joey's data set was more spread out. To figure out if that's a positive thing, look at the situation. I know it's a silly situation, but if each person offered me a rabbit, which one should I take to be sure that the rabbit I would get would have around 7 babies? I would probably go with Jamie's rabbit because her data set was more consistent and less spread out. When her rabbit gives birth, I can be sure that the size of her litter is closer to 7 rabbits. I hope these examples help you as you calculate and interpret measures of variability.